Welcome to The Explainer. Today, we are absolutely cutting through the noise and demystifying the whole academic research process. We're using the MEM 111 Research Methodology syllabus from Purbanchal University as our trusty guide to build a really comprehensive crash course for you. So let's just dive right in, shall we? Now, before we even start looking at the how, we've got to establish the what. What exactly is research? Well, in an academic context, it's highly specific. It's not just Googling things. It's this systematic investigation of a subject to actually gain new, actionable insights. Basically, it's about taking raw data, rigorously evaluating it, and using it to solve real-world problems and really drive innovation. Okay, so here's our roadmap for today. We're going to start with Part 1, the foundation of research, move into Part 2, the research process, and then hit Part 3, choosing your methodology. After that, Part 4 looks at ethics and research quality, and finally, we'll wrap up with Part 5, practical survival skills. All right, let's jump into Part 1, the foundation of research. So the academic world basically categorizes this whole pursuit of knowledge into 3 distinct areas. First, you've got basic research. This is all about exploring fundamental principles in the lab. It's highly uncertain, and honestly, its short-term commercial value is usually pretty unclear. Then we have applied research, which basically takes those raw theories and expands them into predictable technologies. And finally, there's engineering R&D. That's where industry professionals actually use that applied knowledge to develop specific products. It offers low risk and incredibly high short-term commercial value. Moving right along to Part 2, the research process. Turning the total unknown into a highly systematic journey always starts right here in Phase 1, planning. First things first, you have to identify the research problem. Like, what is the actual knowledge gap you're trying to fill? Next up, review the literature. You really want to make sure you aren't just reinventing the wheel. And finally, develop a solid research plan that outlines your methodology, your sample size, and your data collection tools. Think of it like this: you absolutely need this map before you start driving. And that vital groundwork builds directly into Phase 2, execution. This is where theory finally becomes empirical. You collect your data meticulously, and then you clean and analyze it to spot patterns. From there, you interpret those patterns to draw some really actionable conclusions. But here's the thing: the cycle only actually completes when you communicate your results. Whether that's through a report, a presentation, or a published paper, you've got to share what you found. Okay, next up is Part 3. Choosing your methodology. So every researcher faces some core binary choices, and it usually starts with picking between 2 very distinct data universes. Qualitative research is driven by words, observations, and open-ended questions. It's really trying to answer the deep why and how. Quantitative research, on the flip side, is all about objective numbers, hard statistics, and closed-ended surveys to test ideas and answer how many. Now, neither of these is inherently better than the other. They just do completely different jobs for you. Next, you've got to think about the logical flow of your argument. Inductive reasoning starts small and builds up. You make specific observations out in the field, and from those, you piece together a general probable theory. Deductive reasoning, though, it works in the exact opposite direction. You start with a big, established general rule or premise, and then you test it downwards against a specific, concrete instance. So basically, inductive reasoning builds the theory, while deductive reasoning puts it to the test. You also have to choose exactly how you're going to look at your subjects. Take the case study method, for example. This gives you an incredibly deep, context-rich examination of a very specific, small sample. Sometimes it's literally just one single event or organization. It's fantastic for understanding complex realities, but you can't exactly generalize those super specific findings to the whole world. Conversely, the survey method sacrifices that deep context to get broad, standardized data collection across a huge population. Surveys are highly generalizable, which means what you find in a good survey sample usually reflects the wider reality for everyone else. Let's transition over to Part 4, ethics and research quality. Now, because researchers actually hold immense power, they are bound by strict, completely non-negotiable standards. We're talking about things like obtaining informed consent, so your participants know exactly what they're signing up for, all while fiercely protecting their privacy. It means minimizing harm, maintaining absolute research integrity by never, ever fabricating data, and fully disclosing any conflicts of interest that could even potentially bias your results. And look, these guardrails aren't just bureaucratic red tape meant to slow you down. Not at all. They literally ensure that your research is conducted with absolute integrity and a profound respect for human rights. Think about it. When the public trusts researchers, society as a whole moves forward. But when that trust is broken, everybody loses. That strong ethical foundation feeds directly into the actual quality of the research itself. While a truly great study needs a clear objective, two factors really stand above all the rest: validity and reliability. Think of it like a dartboard. Validity means you are actually hitting the exact bullseye you claim to be aiming at. Reliability means if someone replicated your experiment, their darts would hit that exact same spot every single time. Without both of those things, your findings honestly just cannot be trusted. All right, bringing it all home with Part 5, Practical Survival Skills. To ground all this heavy theory in your everyday reality, let's take a look at how your hard work is actually going to be evaluated, using the Purbanchal University grading system as our example. If you're out there chasing that perfect A+ and 4.0 GPA, your target is 90% and above. Hitting an 80 to 89 lands you a solid A. And to successfully pass and earn your degree, you've got to maintain a CGPA of 2.00 or higher throughout your studies. Knowing the target is literally the very first step to hitting it. Next up is a total lifesaver for any researcher out there: reference managers, specifically tools like Mendeley. Look, when you are writing a literature review, your citations are going to get messy fast. Mendeley is this amazing free tool that helps you organize your research documents, automatically generates perfectly formatted citations, lets you collaborate with peers online, and even helps you discover new related papers. Seriously, trust me on this one. Do not try to manage your citations manually. Let the software do the heavy lifting for you. And here's a great practical tip. When you are pressed for time, which, let's face it, is always, don't try to read dense journal articles front to back like a novel. Do this instead. Step 1, read the abstract first so you get the main takeaways. Step 2, unpack the introduction to understand the context. And Step 3, jump straight to the conclusion for the final implications. If you still have questions after all that, well, only then do you dive into the dense methodology and discussion sections. So, we have covered quite the landscape today, from the fundamental theoretical foundations to those rigid ethical guardrails, all the way to some really practical survival tips. At the end of the day, research is the engine of human progress. It's exactly how we build better technology and understand the universe we live in. You now have the structured roadmap to navigate this really systematic process. So the only question left for you is, what problem are you going to research next?